Hello everyone. So today we are going to discuss about ETL and how do we implement ETL on Google Cloud Platform. So ETL basically stands for extract, transform and load. Extract meaning that you want to extract the data from multiple sources. This source may be a database, this may be a file system, this may be any cloud storage like a S3 bucket or a GCS bucket or any of the source from where we can get the data. Transform meaning that if I want to transform some records, basically saying that I have a customer table, I have a product table, I have an order table, and I want to transform these three tables and create another table using these tables with some aggregations by joining, and then we want to join these tables. We want to filter some of the records. All of these come under the transform phase. And load finally means that once you have done all the transformation and you want to store your data in some location, it is called as a load phase. Typical pipeline looks like, uh, so there are two kind of scenario. One is a ETL, extract, transform, and load. Third is the extract, load, and transform. We'll discuss in brief about both. So concept is same still, that we are going to read the data from one place, we are going to transform it, and then we are going to load this. For ETL, let's say we are going to read it from the database or a file or a stream, we are going to transform it. So, and then finally we are going to load it. We may be loading it into the data warehouse. We may be loading it to a cloud storage like a GCS. It's up to us like what we want to use as a sink. Uh, there may be the case that ETL is just an intermediary ETL, basically meaning that we have multiple phases in our data pipeline. Some of the pipeline steps writes into the Google Cloud storage, and only the final results or the reporting layer is present in the data warehouse, which would be consumed by say some tools like Tableau or Power BI or a Looker. So so this is how it looks like in ETL. ELT is again the same thing. It's just that we first extract and load the data, and finally we go and transform it in the warehouse itself or in the GCS bucket. Why there are two different names? Uh, it actually comes from where the Hadoop started. Earlier, we only had the, we used to directly read from the database. We used to transform it, and then we used to load it back into the database or a data warehouse. But since the volume of data increased, we are not able to, process the data efficiently. So with the rise of Hadoop systems, we there came a concept of ELT. This it says that you read all the data from the databases or a single servers which are not able to scale, bring it to Hadoop, and from there you can run all the transformations. So concept is still the same, it's just where you are going to transform the data, that place changes in the ETL and ELT. So let's move ahead to the cloud data fusion. So if you want to build any ETL pipeline on Google Cloud, there are multiple ways to do it. Either you write your own custom code using Spark and then running it in a data proc cluster. You can, have a pipeline already set up using Composer and BigQuery, where you are going to, every time you are going to run a SQL using BigQuery and Composer, and you are going to transform that data and load into another table in the BigQuery, or you may want to move it into some other location. Uh, Cloud Data Fusion is a ETL kind of a tool which provides us the drag and drop facilities that we'll see in some time. It is a fully managed service by Google Cloud. It helps us to expedite the ETL pipeline, building and managing ETL pipeline, because we don't have to write code the that is already written in this particular service. You just have to go to the UI, and you have to just drag and drop, and all the code will be available to you, and you just have to go and execute the pipeline. So If we talk about this, if you see this particular studio is Google Cloud Fusion Studio, where we can read from multiple table, we can join multiple tables, then we can perform some data wrangling operations. We can write in a target location. So we are going to see this how it is done. So you can create a Cloud Fusion Data Fusion instance on by going into this particular service. You can search here Data Fusion. You can see there's a Data Fusion, which is a data pipeline management. You can just click on this and you will come to the instances. Here you are going to create a new instance first. Let's say I want to create some random instance. You can provide a description like what is the purpose of this particular instance. It may be, you can write that it is a production instance which is consumed by a particular team. Where you want to create this instance, US East one, West one. If you are in Asia, then you prefer the region as Asia Southeast one. All of those things can be done here. Versions, we have currently 6.9.2. You can move to older version as well. But since if you are going to create a new pipeline, like fresh pipeline, always stick to the current version. Additions, there are three different additions. First one is a developer edition, which gives us the full features about the of data fusion. Basic only gives us basic, like if you want to do from some POC, like we are using the basic edition for learning purpose, then you can use basic edition with the limited capabilities. If you can see, the limitation here is it is only used for, it cannot do the simultaneous pipeline runs. Then we have the enterprise edition. It will be having all the functionalities from the enterprise edition, and it will give us more functionalities like high availability and higher scalability, data lineage. All of those things are available in the enterprise edition. It will ask for data proc service account. You can either you create one account and provide it to Data Fusion, or you can say that it can create the default account. There are some advanced options as well. If you want to enable logging and monitoring, if you want to enable private IP, or if you want to use encryption like a customer managed encryptions, you can add it here. You can also add labels like the environment. Here is a development environment and like those, and then you can create the Data Fusion instance. This generally takes some time, so I have already created the instance for our this session. If you see, I already have created a instance named ETL demo, and to view the instance, you can click on this, and it will open a studio. You can also look into the instance specification. You can click on the instance name, and it will show you like what is the addition that we have chosen, what is the name of the instance, stack drivers, and monitoring. All of these things are disabled. And other like we don't have any private IP, and encryption is Google managed. So all the details you can see over here. And region, if you see, I use the default US West one region. Once you click on the view instance, you will come to this screen. Here, there are 5 different things that you can go to. You have a Wrangler. Wrangler basically is used to transform your data set. You can clean your data, or you can add new columns. Everything can be done, without writing any code. You can integrate, you can run the ETL pipeline, like integrate as in read from one source and write to another source, extract, transform, and load. All of these things comes under this. Discover and Govern is a metadata management platform provided by Data Fusion, where you can, manage your metadata. And you can also see the lineage, like my Data Fusion job read from this particular location, and then all these transformation. Finally, we created a target table. So all those images can be, seen over here. Then monitor and manage it. Like if you want to make some changes at the system level, or if you want to see the dashboard, these all options are there. So we are going to look into the integrate part of this data fusion. You can click on the studio like this, and you will come to a screen of where we are going to create the data pipeline. Okay, so this is how it looks like when you click on the studio. So this is the data fusion studio. It has multiple options. If you see at the left, we have a source. In the source, you can select multiple sources. Like if you want to read the data from ADLS, Azure Data Lake, Amazon S3, BigQuery, Bigtable, Dataplex, Data Store. Even Excel is also available. FTP is deprecated now. Files, GCS, HBase. So there are multiple sources available, like major sources from where we know that data resides in Amazon S3. So you can connect it there. You know that data resides in this BigQuery. You can read from that. PostgreSQL, MySQL, all those options are available. In this sync also, again, the same options are available. Like if you want to write the messages to PubSub queue or a Kafka producer, or if you want to write the data in HBase or BigQuery tables, all those options are available. Then if you want to migrate your data in between, like based on some condition, you want to write data in some you want to perform some action based on some conditions, you have those options available as well. Error handlers are also available, like if there's any error in the pipeline, what do you want to do? If you want to push a message to Kafka, if you want to raise a transaction alert, all those things are available. Analytics, if you want to do some join operations or a group by operations, distinct operations, all those comes under the analytics tab. Then on the transform, there are multiple transformation available, like you can do XML parsing, JSON parsing, you can do a transpose, you can have some JavaScript based transformations as well. So all those transformations are available over here. On the pipeline, there are two type of screens available. Like if you want to use a batch or a real time. So we are currently working on a ETL batch based ETL. So we look into the batch pipelines. Now, so this is how Studio looks like. Some more overview is basically we have created the instance. It is a unique deployment of Cloud Fusion. Then execution environment, whenever you run a data fusion, it will create a data pro cluster. And this data pro cluster will be a ephemeral cluster, meaning that as the job starts, this cluster will get invoked. This cluster will be created. All the job will keep on running here once the job is completed. It may be success, it may be a failed job, but yeah, once the job is completed, the cluster gets deleted. Okay. Auto scaling is also available. Then we have a pipeline and we'll see how pipeline looks like and pipeline nodes. As I mentioned, there are two type of pipelines, batch pipeline and real pipelines. So let's look into the data that we have, and we'll try to create one ETL pipeline here. So we are going to extract the data from one source. We are going to transform using joins and wranglers, and then finally we are going to store the data in the GCS. So there are three type of data that we currently have. We have the customer data, which has two columns: customer ID and customer name. Customer ID is C1, C2, C3, C4. Names are John, Doe, Alice, and Bob. We have a product table. Product table consists of three columns. ID column, which is a product ID, P1, P2, P3, P4. Name of the product, like Lay's, Pepsi, Dairy Milk, and Doritos. And then price of these products, like the price of Lay's is rupees 20. It is all in INR, Indian rupees. So these are the price of these products. And then whenever a person purchase something from this platform, there's a order that gets generated, and there's a order table which will be containing say 4 columns. It will be containing the order ID, customer ID, product ID, and quantity of the product. So if you see the order ID O1, there were two products bought by a customer C1, product P1 and P2. So quantity of P1 is 2 and quantity of P2 is 3. And if you see the products P1 and P2, so it says Lay's and Pepsi. So two Lay's and 3 Pepsi. So these two were bought by the customer C1 with order ID O1. What we are going to do, we have this data in GCS location. I have uploaded it. I'll show you. We are going to read these three data sets. Then on these data sets, we are going to join these data sets, and we want to know what is the amount, or what is the total amount that is spent by the customer for say product P1. What is the total amount spent by the customer C1 on the product P2, something like that. Okay. So let's look into this. So first thing first, we want to have a source. If you see the source here, it says that uh, there's a bucket that I have created, like organization data lake. There we will be having three different folders: customer, order, and product. And then there would be a summary folder where we are planning to save our output. Inside the customer, if you go, you will see that there is a file available. There may be multiple files for customers. We need to pass the location of folder and data prop. Since it uses Spark in the backend, it will read all the files from the folders that we have defined. Okay. So let's get started. Here, so whenever you want to create any source, you just have to go there and click on that source. So I want to create a GCS bucket. I can do it like this. I can create another bucket. So from the source, we have three sources, source 1, 2, and 3. One source is called as a customer source. So you can click on the property and come over here. I'll say that this is a customer. Then it will ask for a few options, like if you have already created some connection, you want to use it. It will ask for a reference name. If you are using an enterprise edition and you want to see the linear, you have to give the name of the some name to this particular GCS bucket, GCS connector. Okay. Now we'll say that okay, the past of customer is this. So we are going to write it over here, something like this. It will say that read the data from this location. Our data is in CSV format. This we have our header row, and we can ask for a schema. Then it will show you that okay, there are these two columns which we are going to use from the customer data. So if you see, there is a ID column and a name column that we have, and here also we have these two columns. After after providing other informations, like you can have other options as well available. You can just pass on, like if the encoding is UTF-8 or not. So since we are using UTF-8 encoding, we are not going to change it. You run a validate to see whether all the properties that are required are properly set over here. So it says that there is no error found, so we are good here. Now, similarly, we can have order table. We can say that it is an order kind of a connector, which will read the order data. I will say that this is a order. We can give a reference name as order. Over here, we can pass the folder name as ORD. And the format again here is CSV. So we are going to select CSV. And you can just verify. You can say that, okay, first row is header. Just look into the schema. So it will go read some sample records we say that the read 1000 sample records, then it will go and read 1000 records and identify the schema. If you see, there are four columns: ID, customer ID, product ID, and quantity. And we also have these columns in our CSV as well. So far so good. Okay. There is no, I don't think anything is missing. So let's validate and confirm. Yeah, it says that no error is found. Similarly, you can do the same thing for a product table or a product data set. I'll say that reference name is product. I come here and give the path of the product data set. Format again is CSV, and we have the header row. So we'll say header is true. Once you look for the schema, it will show you over here that, okay, these are the columns. If you see, price is inferred as a int column, since in our data set we haven't written something like this 20.0. But if that is the case, you can, come here and say, no, you have inferred it wrongly. Let's create it. Let's change the data type to double. So price should be double because we can have 20.5 rupees, 30.2, something like that. So we should have a double data type over here. So all those things are available. If you see, we don't have any error found. Now, let's say I want to I want to join these tables. Okay. So here I can go to analytics. I can click on a joiner. I can connect these two. Let's say first join order and customers together. I'll go here. I'll say that this joiner is called as customer order join. And if you see, since we have given these two tables, you can see that this schema is already inferred. So we have the options like, okay, you want to have this column, you can rename it. If you want to rename it, let's say I'll say this is a cust ID and this is a first name. Similarly, on the order table as well, I can say that this is an order ID, ORD ID, and we have the cust ID available. And since this is a original coming from a customer table, let's give it original customer ID, something like that. You can change the columns. Then join type, let's say we are going to do an inner join just because we want to see only customers who have ordered something. A join condition, I will say that I want to join on the ID of the customer and cust ID of the order table. And yep, if you want to have some other options available, like how many number of partitions do you want to join on null key or not, all those things are available. And if you see the get schema, you will see that in the output, we have these columns available like O cust ID and then cust name. So I don't want O cust ID. And we just want these columns like product ID, customer name, and yeah. So let's run a validate and see no error is found. So let's create one more joiner. This joiner will join these two tables. So this will join this product table and the output of customer order join. I can say that we can set the property and say that this joiner is called that customer order product join. Okay. Now, if you see from the since we have connected these two particular connectors, you can see that, okay, these are the columns available. You can rename it if you want. I'll say that this is a product ID. Name is, we can say this is a product name, something like this. Then on the price, we can say that, okay, let's keep it as is. From the order table, again, we can select the columns that we want. Join type is inner. I'll say I want to join from the product ID to the product ID of the customer order join. And if I go and click on get schema, I can see there are multiple columns available. I'll say that, okay, I don't want this column. I don't want to have a prod ID column. I don't want to have, do I want to have any other columns? That's fine. So we are going to validate it. And if you see that that says no error found, so we are good here as well. Now I want to let me create some space over here. Now to there are two columns like quantity and price. So quantity is coming from order table and price is coming from the product table. So I want to multiply these two things. So 2 into 20 should be 40. So I want to have a final table which will have some columns and the amount spent on a particular product. To do that, there is a component called as a wrangler. I'll go to this transform. There is a something called as a wrangler. I am going to select this wrangler, and here I am going to connect it with the final join table that we have, and we can name it saying that okay, this is a this wrangler is going to add new column, something like this. Now there are two ways to uh, provide that new column definition. So either you can write in JavaScript some languages, or you can write in SQL. So for this JEXL format, we can just go and there is a complete documentation around it. If we want to see through, it will give you the way to write this particular. If you want to add a new column, you can write it over here, something like set column, and then inside set column you can pass the column name like total price, and you can give the condition like I want to do the multiplication arithmetic. I want to perform some arithmetic operation like multiply, and I want to apply this on two columns called as quantity and price. Same thing you can write in SQL as well. So we are currently going to stick with this particular syntax. You can write it over here, and then you can validate it. So also here you have to add some new column. So the column that you're going to select over here, you can write it over here as well, like total price is something that I want to propagate from this as an output of this data wrangler. And yeah, the column name is total price, and you can set this. Just to confirm with this syntax, let me just go and see whether I have written it properly or not. So this particular, yeah, so it is something like this only. The syntax is the set column is set hyphen column. So just to be pretty sure, let me copy it and paste it over here. So it says set column in that you want to create a new column named total price, and you want to apply some operations called as a arithmetic operation. You want to multiply quantity and price. So here it can be an add operation as well. So multiple operations are supported. Just to showcase this particular use case, we are going to use the multiply operator. And you can validate if there is something wrong over here. So I don't think anything is wrong. It's just that from you can remove some columns that you don't want. Like I don't want a customer ID, or I want to select only a few columns. Like I can have a product ID, customer ID, order ID. I don't want a price column. I don't want a quantity column as an output because I already have total price now. So I just want to have a like 5, 6 columns. And once this is done, finally I want to store it in another GCS location. So I can select sync as a GCS, and in this I can connect it to a Wrangler, and we can perform some we can add some properties over here. I'll say that this is a summary of our orders. So I'll label it as summary. Bucket name is gs colon double slash. Then we'll go and see what is the bucket name. Okay, and I give the bucket name, and finally I am going to save this in a summary folder like this. Format I want to keep it CSV. I want to have header as well. location US is fine. If you want to have some add some prefix, it's fine. You can provide it over here. And then finally, you can set over here as well, like what are the final output columns that you want. I don't want to remove any columns since I have already removed it earlier. So I'll just see and validate it whether all the details are correct. So now this is the flow that we have. There is a way to, if this particular pipeline becomes more complex, then it won't. If you want to see, you can just click on this particular hover and just see where wherever you want to go. So if you say if summary is not visible here, so I can just click here and scroll it towards right, and we can see, okay, this is the summary. Now you can give the name of the pipeline. I'll say that customer order summary 1. And you can give some description also if you want. If you see, this is saved. Once it is saved, you can deploy it, you can export it like this. So this particular flow will be exported as JSON. Whenever you want to, import this, you can just click here and you can give a path. And let's say someone else wants to work on this, you can push it to GitHub repo, and from there you can read it. Okay, so it is a JSON file. So you can open this JSON as well. It will take some time. I have mistakenly clicked on Visual Studio. But yeah, idea is pretty clear that you can export this particular flow and you can reuse it. Okay. Let's deploy the other options as well. If you want to configure, you want to add some configs for the resources, how many CPUs, how do you want to set your pipeline alert on all the engine config. So Spark is supported. MapReduce was supported, but now it is deprecated. And other pipeline configs that you want to set, you can set it here. If you want to schedule it, you can click and say that I want to run it daily at say 1 a.m. and maximum concurrent run allowed is 2. So, and this pipeline runs daily. If you want to say weekly, then we can say weekly. So all those things you can set over here. And finally, after you have saved it, you can deploy it. So once you click on a deploy, it will go and create the deployment. It will create the pipeline, and you can go and in the pipeline tab you can see. Now if you want to run this, you can click run over here. Once you click on the run, it will start running. It will first go and it will first provision the cluster. Once the cluster is there, it will start, and then your job will keep on running. Once the job is completed, it will it will go there and write the output in the proper location if it is succeeded. If it is not succeeded, it will fail and it will provide us the log over here. Okay, so let's where it went. Let's go to the pipeline options. Let me go to the list. And if you see over here, so this was the run that I had performed some time back. And this flow is similar to what we have created. We have to just go and click on run. Once you click on this run option, you will see that the status will again go from succeeded to provisioning. It will take some time to provision the cluster. Generally, this run took around 7 minutes. So it will first provision the cluster. In the cluster, then it will going to, it will be going to execute this particular flow. If you see, the compute profile is data proc, and you can see the history here as well, like how many version of this pipeline was available. So there were some issues, small issues while building this pipeline. I fixed those issues, and every time you can give the summary as well. And anytime you want to go and to this version, you can say restore. So sometime it might happen that the earlier version was better than the newer version. You can just go and restore that version. In the summary tab, it will show you the run histories, how many time it got failed. So my previous two run were failed and the third one was succeeded. And if you see the duration, it says 7 minutes 9 seconds. So initial 4 5 minutes goes into cluster provisioning. Once that is done, uh, the job starts. Then once if everything goes fine, it will get succeed in some time. Otherwise, it will fail. And if you see, I just invoked the new run. It is currently in the provisioning state. So all the things are available over here. It gives you the warnings and log errors as well. If you see, there are multiple warnings and previously were some errors in 3 runs. So it has given us those chart as well. How many number of records in and out? It will, you can go here and see the output. So if you see here, the product table, it says that four records. And if I go into the data set, you can see that there are 4 records available, P1, P2, P3, and P4. Okay. So these are different statistics that is available. Schedule again, if you want to do something over here, if you want to stop your job, if while running you want to give some arguments, runtime arguments, that is also possible. In the action, if you want to edit this particular pipeline, you can go there and you can edit or duplicate. If you want to push it to GitHub, you can integrate it. So you can push it there, push to remote, and all those things are available. So it will take some time. So I'll pause this video for a couple of minutes, and once it is in the running state, we'll resume. So if you see, we have the status as running. It will take 1 more minute, I guess, based on the previous one, and then it will get succeeded or failed. So let me resume again when it's succeeded. So if you see, the status is now succeeded. It took 6 minutes and 59 seconds to run this particular flow. And let's go and validate the summary. So if you see, there is one run that I created first to verify the flow, and this is the newer run that we just performed. So if you see, we have created this particular data fusion pipeline that we have created. It has created the part files. Let me download one and see how it looks. So let me open the download folder and let me open this. Yeah, if you see, we have the columns like customer name, order ID, customer ID, total price, and it has the total price for the customers. So customers even bought two quantities of Lays. If you remember, the customers even bought two quantities of Lays, and the product like price is 20 rupees. And as an output, we can see that the total price is 40 rupees that customer has to pay. So similar to that, it would be for others as well. You see multiple files here, R0, 1, 2, 3. So when Spark job gets executed, it creates part file in multiple parts. Since this is a small file, so we have 2 3 records in each file. But yeah, if the volume is pretty high, then it will create somewhere around 100 MB part files. Okay. So this is how data fusion works, and this is how you can perform ETL on Google Cloud. So you have to extract the data from multiple sources. You can do join, you can do wrangling, and then finally you can write your data into your target location. It may be a GCS, it may be a BigQuery. So we chose to write in the GCS location. Okay. So yep. Also, if you go and look at the summary, it will say that this one is the latest version, and the summary will show that the newer run that we just executed is now succeeded. So this is how you can leverage Google Cloud Platform and Google Cloud Data Fusion to build your ETL pipelines. Thank you.